there, we're going to look at 3.5 today on solving quadratic equations by completing the square. A lot of what we're going to talk about today we've done in Algebra 1, but our objectives are that we're going to be able to solve quadratics by using the square root property and solve them by completing the square. And our standards are looking at being able to analyze the structure of binomials, trinomials, and other polynomials to rewrite equivalent expressions and be able to translate between equivalent forms of a function and explain the different properties. And so we're going to look at example 1 here, and we're going to look at just solving using the square root property. And so with this first example, x squared minus 49 is equal to 0. I can do one of two things. I can first take it and understand that this is a difference of squares and solve each one for the two pieces, right? And that's what we talked about back in section 3. But the other way when we factored, section 4, not section 3. And then the other way we could do this is to add the 49 to both sides. And we get that x squared is equal to what? 49, right? And then I would take the square root of both sides. But remember that when I take the square root of something squared, the number inside, the x itself, right? When I square it, it has to come out what? Positive. Well, the number inside could have been positive or it could have been negative. And so when we take the square root of something that was squared, we've got to put a positive and negative symbol on the other side, because what we're equal to could be both positive or negative, and the square root of 49 is 7. And so this has two solutions, positive 7 and negative 7. Okay? And so we look at example B here, one that's a little bit more involved. Well, look at this part on the left-hand side. And remember that one of our perfect square trinomials, right, is a squared minus 2ab plus b squared, and that factors out to a minus b squared. Well, the x squared does split up to x and x. The 64 splits up to 8 and 8. Remember, I got that 2, so x times 2 times 8 is 16, so this matches. And so x minus 8 squared is equal to 25. Again, that goes back to that perfect square trinomial that we talked about in section 4. From here, solve using our order of operations, right? At this point, we're to the point of exponents, because that's what's outside the parentheses. So I take the square root of both sides. Again, I need that positive or negative in front, because the number inside that was squared could be positive or could be negative. So I'm going to get positive or negative 5 on the right side, because the square root of 25 is 5. Now I can add the 8 to both sides, and x is equal to 8 plus or minus 5. So this plus or minus that's here means I have to do both operations. What is 8 plus 5? Well, 8 plus 5 is 13. Or I can go the minus route and get 8 minus 5, and that's going to give me 3. And so my two solutions are 3 and 13. Not parenthesis, brace, right? And so if I go back and test these, right? If I go 3 squared, that's 9. 16 times 3 is negative 48, because the minus, right? So 9 minus 48 is negative 37. And negative 37 plus 64 is 25. And if I use the 13, that's 169 minus 16 times 13. So you're talking 16 squared is 256. So somewhere around 200. And don't have a calculator right in front of me at the moment. But plus the 64, that would again give us the 25. Okay, and so those are our two solutions there. And so let's talk about some steps to complete the square. Again, these are steps that you should have seen in Algebra 1, just reviewing this. So the steps to complete the square of a quadratic that's in the form of x squared plus bx. The key is that there is no a value other than 1 in front of the x squared. Do the following. First, take half of the b. So let's say I've got like x squared plus 10x, right? So half of the b. Well, half of b would be 5. And then it says to square that. So now I'm going to square this, and so 5 squared is 25. And it says add this result back to here. And so I'm going to add 25. And then it says this is a perfect square trinomial, so now we're able to factor it, which means that it's going to come out. So my x's come out, my 25's come out, and the whole point of this is that this works out because x plus 5, you're going to take this number here, squared, is the factorization. Now, if this was set equal to something like we're going to see in the problems below, we could then set this problem up to solve out, okay? So let's look at example 2. Solving equations by completing the square. X squared plus 4x minus 12 is equal to 0. When we're solving by completing the square, the key is, go back to the process, right? We want it in this form, which means I need the constant on the other side of the equal sign. So my first step will be to add the 12 to both sides. And so I get x squared plus 4x. I'm going to leave a blank here so I can fill that in later, and the 12's on the right. And so now, to complete the square, I'm going to take half of the b. So what's the b? Well, the b was 4, so I take half of it. And so that's 2. And then I'm going to square it. And so 2 squared brings me back to 4. And so I'm going to add 4 to both sides of this. Because remember, what you do to one side of the equation, you have to do to what? The other. And so the right side is going to give me 16. The left side is what's going to factor. Remember, the whole point in completing the square is that it factors to a perfect square trinomial. And so we'll get the x, and then the square root of this is 2 with the plus sign in the middle, and squared. And so now we're able to take the square root of both sides. Don't forget your little plus or minus. X plus 2 is equal to positive or negative 4. A couple steps left here. We're going to subtract the 2 from both sides. So x is equal to negative 2 plus or minus 4. If you want to leave the positive or negative 4 in front and then minus the 2 out back, that's fine. And so you get positive 4 minus the 2 and then negative 4 minus the 2 and get the same answers. It's just a matter of just using the commutative property to switch around this order of addition. And so x is equal to negative 2 plus the 4, that is 2, and x is equal to negative 2 minus the 4, that is negative 6. So my two solutions are negative 6 and positive 2, and remember you should order least to greatest, okay? And so I want you to try example B here. X squared plus 6x minus 10 is equal to 0. Try that one out, try the steps, do what we did up here. So pause the video for a second, try that problem, and then come back. All right, so let's look at x squared plus 6x minus 10 is equal to 0. Remember, our first step is going to be add or subtract, depending on the signs, the constant to the other side. And so I'm going to get that x squared plus 6x, again, I'm going to leave a blank here so I have space to work later, is equal to 0 plus 10, so that's 10. Remember, this right side might not always be 0, so pay attention to what you have there. And so I'm going to take the b, and the b is equal to 6 in this case. I'm going to take half of it. And so that gives me 3. And then I'm going to square it. And 3 squared is 9. So I'm going to add 9 to both sides of this equation. And so the right side gives me 19. The left side will factor out x plus, remember it's the square root of this number that we just put here, or it's the number before we squared it. So the 3 plus, because of this sign, right, squared. And so now I'll take the square root of both sides. Don't forget your plus or minus. So x plus 3 is equal to positive or negative square root of 19. And then we can subtract the 3 from both sides and get our x by itself. We get negative 3 plus or minus the square root of 19. Now, this is a perfectly legitimate final answer. We don't need to simplify it unless we need the decimal for something specific. And so when we do the square root of 19 in our calculator, we're going to get a number that's about 4.4 or so. It's to 3 decimal places, it is 4.359 with rounding. That's 4.35889. And so then we would add and subtract this, and we would get that x is approximately equal to negative 3 plus the 4.359, and x is approximately equal to the negative 3 minus the 4.359. And so this is going to give us negative 7.359. This one will give us 1.359. So again, we can represent this answer one of two ways. If we need the precise answer, that's this, negative 3 plus or minus the square root of 19. That's a perfectly legitimate final answer. If we need the decimals for rounding, or for whatever application we're dealing with, we will then put those two decimal answers. And again, sometimes when we deal with application problems, the negative answers might not make any sense because our answers could only be positive depending on the circumstance. So pay attention to that as well. And if I'm dealing with money, I'm not going to round to 3 decimal places. I'd only round to 2. So again, pay attention to context as you look at these problems on what you're going to simplify. Okay. Example 3 is dealing with completing the square when the a, the number in front of x squared, is not 1. Because we said in the steps of completing the square that the a had to be 1 to complete the square. And so there's a couple of different methods that people will use to solve this out. I'm going to show you one that I feel is the easiest to remember. It's not always going to be the easiest to calculate, but it's the easiest to remember. And so we're first going to add the 1 across, just like we've done before. So we get the constant on the other side of the equal sign. And so I get 3x squared minus 2x is equal to the 1. So how could I get this a to become 1? Well, right now the a is what? Well, it's 3. So how can I get the a to become 1? Well, the 3 is attached to the x squared by multiplication, so to undo multiplication, I would do what? Divide. And so I'm going to divide everything by 3. That cancels that. So I get x squared minus 2/3 x is equal to 1/3. And I'm going to leave my little gap here at this step. So now my b is 2/3. I know what some of you are thinking right now. We're going to divide that by 2. Well, remember that, so 2/3 divided by 2 would be 2/3 times a half, which is 2/6, which is 1/3. Okay, so we got that. Now remember that we're going to take this value and do what? Square it. Well, now I just got to square a fraction. That's easy because you square the numerator, square the denominator, and so that's going to give us 1/9. And so I'm going to add to both sides of this equation 1/9. Now, the nice part about the left-hand side is the left-hand side, there's no work to do because you take the number before you square it. So it's going to be x minus the 1/3 squared. The right side, you got to do a little bit of work because our denominators are not the same. So 1/3 would be 3/9, and so it's going to give me 4/9. And so now I'm going to take the square root of both sides, plus or minus. Square root cancels the square. X minus 1/3 is equal to positive or negative. Don't forget your positive or negative. 2/3. Because the square root of 4 is 2, the square root of 9 is 3. Because remember the property is that if you take the square root of a over b, you take the square root of a over the square root of b. And so now I'm going to add the 1/3 across, and so I'm going to get 1/3 plus 2/3. And so finishing off our answer here, we're going to get that x is equal to 1/3 plus 2/3 is 1, or 1/3 minus the 2/3 would give us x equal to negative 1/3. And so my two solutions, negative 1/3, positive 1. Okay. And so again, the key thing here, we've got a fraction involved in here, but the fraction's not terrible if we go back to 4th grade math for a second and remember how to divide fractions, right? Just remember, multiply by the reciprocal, okay? So like we did before, I want you to pause the video here and try example B. 2x squared plus 11x plus 15 is equal to 0. So pause the video here, try this example. All right, so 2x squared plus 11x plus 15 is equal to 0. And so again, I'm going to subtract the 15 first from both sides. So I get 2x squared plus the 11x is equal to the negative 15. And then remember, we're going to divide both sides, which means I divide everything by this 2. So I get x squared plus 11 halves x, leaving my gap, is equal to negative 15 halves. Nothing reduces here. And so now I take my next step, which is I take the b, which is 11 halves, and I'm going to divide it by 2. So that means I'm doing 11 halves divided by 2. So that's 11 halves times a half, which is 11 over 4, which doesn't reduce. Okay, so again, if you write out what you say. It's 11 halves divided by 2. If you write out that step, it's not confusing, I promise you. Okay, again, this isn't hard, but I know how some of you are with fractions. Okay, and so now I'm going to take both sides and square it, or the b squared, the b over 2 squared. And so I'm going to get that this is equal to 121 over 16. Ugh. Okay, so now I'm going to add that to both sides of this, 121 over 16 plus the 121 over 16. Okay, and so when we do that, we're going to get x plus, again, remember using the number in here, 11 over 4 squared is equal to, well, now I got to multiply both these by 8, so negative 15 times 8 is negative 120. And that would be the 2 times the 8, which is the 16 now. And so I'm going to get negative, this is negative 120 and positive 121, so this is just positive 1/16. Well, that ain't so bad, right? And so my next step, take the square root of both sides. So square root, don't forget your plus or minus. X plus 11 over 4 is equal to positive or negative. Square root of 1 is 1. Square root of 16 is 4. Ooh, look at this, 4 and 4. All right, and so last step, subtracting the 11/4 from both sides. And so we're going to get that x is equal to negative 11 over 4 plus or minus 1/4. And so adding these together, remember, denominators have to be the same. They are. And so I would get x is equal to negative 11 plus 1 is negative 10 over 4. So that's negative 5 halves. If I do the subtraction, negative 11 minus 1 is negative 12 over 4, and that's negative 3. And so my two solutions are negative 3 and negative 5 halves. Negative 3 is to the left of negative 5 halves. So there you go. And so the process just repeats with having imaginary solutions, right? So that's not anything different. We're still going to do the same steps. It's just that instead of having a nice rational or irrational solution, we have an imaginary solution and we deal with the i's at the end of the problem. So same steps here. So you could probably beat me to this on some of this, but minus 11 on both sides. X squared plus the 4x, leave your gap, equals negative 11. Our b is 4. We divide it by 2, so that's 2. And then we're going to square it. So 2 squared is 4. So I'm going to add 4 to both sides of this equation. And so the factoring out would be x plus 2 squared. Remember that sign there and this number before we squared it. And so the right side is equal to negative 11 plus the 4 is negative 7. And so I take the square root of both sides. Let's not use green again. And square root of both sides, right? Square root, positive or negative, still need that positive or negative, that ain't going to change. And so x plus 2 is equal to positive negative square root of negative 7. Now, go back to what we talked about in section 3, right? Split this up. The negative 1 and the 7, square root. This is your I, the 7 doesn't separate out. So x plus 2 is equal to positive or negative I root 7, because we don't leave negatives under radicals. Not any, at least not in terms of square roots. And so then we'll subtract the 2 from both sides. And so x is equal to negative 2 plus or minus I root 7. Now, when we looked at 3.3 and we talked about complex numbers, we normally had the b in front of the I. This is the one exception that we put the real number part of the imaginary, right, the multiplier, behind the I instead of in front of I, because we want to make sure that the I is not under the radical as well, because then you'd have the square root of negative 1. It's not going to make sense. Okay, and so this is our final answer. There's nothing else we could do to it. There's no decimal answer that you could get from this. And we'll talk more in pre-calculus about the complex coordinate plane and into calculus as well. But for now, this is just our final answer. And so again, I want you to pause real quick. Take a chance to do b here, x squared plus 4x plus 5 is equal to 0. Solve this one out. All right, and so we're looking here at x squared plus 4x plus 5. So minus the 5 from both sides. x squared plus 4x is equal to the negative 5. And so we're going to take our b, which is 4, we're going to divide it by 2, which is 2, we're going to square it, so 2 squared is back equal to 4. All right, we got to love when we deal with 4s because it just comes back to 4. And so we're going to take the square root of, or not square root yet, we're going to factor this side, x plus, and remember the number before you square it, 2 squared, and negative 5 plus 4 is negative 1. And so now we'll take the square root of both sides. Don't forget your plus or minus. So positive or negative, square root of negative 1 is just I. Why do any work? It's just I. So then we'll subtract the 2, so x is equal to negative 2 plus or minus I. Now, this leads us to something we're going to talk about in chapter 4, that imaginary roots always come in pairs. So keep that in your brain, and this is why imaginary roots come in pairs, because when we take this square root, we end up with that plus or minus. And so understand that imaginary roots will always come in pairs, also irrational roots when we get irrational solutions, but both come in pairs. Keep that in mind again for chapter 4. Okay. All right. So last example we're going to talk about here is being able to use completing the square to get us to vertex form. And so everything we've done so far has been one variable equations solving for the x. But now we're going to use this to go to vertex form. Now we talked back in section 1 that the vertex form is y is equal to a times x minus h squared plus k. And so how do we get this to look like this? Well, there's a few steps. And so we're going to have the y equals negative 3x squared minus the 10x plus the 12. And so our steps are still going to be the same to get this factored out. So I'm going to subtract the 12 from both sides first. Well, let me get it all the way across to the other side. And so I get y minus 12 is equal to negative 3x squared minus the 10x. I can divide both sides by the 3. So everything here is getting divided by the negative 3. And everything on this side will get divided by the negative 3. Now, there's a reason why I'm not dividing this into each individual piece. You'll see that in a minute. Okay, and so we're going to get y minus 12 all over the negative 3 is equal to x squared minus 10 thirds, actually be plus 10 thirds x at this point because the negative divided by negative is positive, right? And so my b is equal to 10 thirds. Remember, we're going to divide that by 2, so 10 thirds divided by 2 is equal to 10 thirds times a half, so that's 10 sixths, which is equal to 5 thirds. And so now we're going to square this and square this, and so we get that this is 25 over 9. And so I'm going to add 25 over 9 to both sides of this equation. Because remember, what you do to one side, you have to do the other, right? And so I'm going to take this and take x plus, remember we take this before we squared it, x plus the 5 thirds squared. The right-hand side gets to be a little tricky. So I've got the y over negative 3. We could reduce this to plus 4. And then plus the 25 over 9. And so again, we've got some tricky stuff going on here, but I'm going to show you a little trick here. Okay, if I multiply both sides by this negative 3 that's here, all right? If I multiply both sides by the negative 3, that's going to get this pesky negative 3 gone on this side. And so, but it will still multiply to the others, right? And so I'm going to get y minus the 12 plus 25 thirds, but it's not plus anymore because positive times negative is a negative. This 12 going to thirds would become 36 over 3. So y is minus 61 thirds is equal to negative 3x plus 5 thirds squared. Again, this isn't pretty, but it is the correct steps. Again, if the numbers are nicer, this works out a little easier. We're going to add the 61 thirds to both sides. And so what we end up with is y equals negative 3 x plus 5 thirds squared plus the 61 thirds. And so the question asks us to identify the vertex. And remember, the vertex is the h and the k that are here. Remember, the x does what? It lies to you. It lies, it lies, it lies. So negative 5/3, comma, 61 thirds. So this would be at negative 1 2/3, and this would be at 20 1/3. So this would be in quadrant 2. This would be opening down because the a is negative, right? So again, we could talk about the graphs of this. But there is that. I'm going to stop there because we're at 25 minutes. So the word of the day is to complete the square. Again, the word of the day is to complete the square. I hope y'all have a great day, a great weekend, because it's Friday. So see y'all later.